Forget everything you know about Bartop arcades. Probably not that much, but in this video we're kicking off a new project by designing something special. It's unique, it's beautiful, it's a new barcader arcade. Stick around. Today we're starting off a new project, a new design, a new set of challenges. Originally codenamed the Curvecade, and today I'm going to call it the Barcader. While it's still early, comment below on which name you prefer. Either way, it's a Bartop arcade, but not like anything you've seen before. Let's rewind a bit and talk about its origin. By now you know I like design. Original, creative, simplistic, well thought out design. Sometimes it's a product interface, other times it's a circuit board layout, but regardless of the context, a new project's always an opportunity to put your creativity and applied skills to the test. Now this project's a few months old, but before now it's only occupied my idle thought. Today marks a milestone which I believe I've solved for most of the challenges that it presents. And that means it's time to build this thing. But before we do that, we have to design it. Now if you're into retro arcades, then you probably already see what's unique about this design just from the thumbnail. If not, let's discuss it. Search the internet for retro arcade and you've got tons of machines. Full-size, mini, laptops, handhelds, and bar tops. Basically a hybrid machine that sits on a counter, table, or bar. This design falls in that category. But if you look closer at the search results for Bartop arcades, they all start to look the same. I wanted to do something different, creative, unique, and simple. Generally that means risky, one of a kind, and complicated. Therein lies the challenge. So to put myself to the test, I wanted to employ a curved monitor in a vertical orientation to create a natural and flowing arc for the machine. Working through the design and configurable options of the emulator platforms, the benefits of the form factor could lend themselves to incorporating a digital game marquee and bezel that can give you a more immersive experience, allowing the machine to morph into just about any game that's played, changing its appearance and ultimately the retro nostalgia of the experience. Now that's pretty cool. To get started, I need to procure a curved monitor. Once purchased, while this could be mounted as is without any enclosure for easy results, a complete teardown would be necessary to support my goal of minimal simplicity in the design. To save budget, this design was built around a 23-inch 1800R curved monitor. 1800R is the radius of the curvature of the monitor. Curved monitors range anywhere from 1000 to 4000R, which incidentally correlates to the maximum monitor viewing distance. With curved monitors, the experience degrades if you exceed the radius of that distance from the monitor. It's basically going against the whole purpose of keeping the monitor parallel with your seated focal length. That doesn't really matter for this build because I'm rotating the monitor vertically and using the curvature for a whole other purpose. For multiple reasons. One, for the minimalistic style and effect, and two, to create a vertical arcade that incorporates a digital bezel, marquee, and cabinet graphics on a single monitor. Now before I can start designing in Fusion360, I need to get the dimensions on the monitor. So first task in order was to tear down the monitor and see what I'm working with. Now the Samsung monitor that I used came apart easily, only a couple screws and a snap fit bezel. And the TV control on this particular monitor is a single D-pad, which makes it very discreet and easy to add to the new cabinet. With the raw monitor components removed, I'm good to go. The remaining components of the system will be a Raspberry Pi 4, exhaust fan, button controllers, a power supply, power distribution board, and custom configured emulator setup to organize all those graphics in a unique way. Let's talk about designing this thing, but before we do that, let's take a quick break. This video is sponsored by Altium. It's the software I use to design my project circuit boards. If you haven't taken a chance to download a free copy and see what you're missing, I've put links in the description, and with Altium Designer, creating these projects is a piece of cake. It's fast, accurate, and fun to use. The efficient workspace has some of the best features in the industry, and through all phases of your development, you'll be empowered to do your best work while you grow into its more advanced capabilities. The link below will allow you a free trial copy of the software so you can check it out and see what enterprise class ECAD feels like. Now back to the project. To get started, I dove into Fusion360 and began to model the curved monitor component, as this would be central to the arcade's design. With the mocked monitor in place, I sought out models for the Sanwa joystick and buttons, and I always start with grabcad.com and go from there. As these are all pretty standard objects, I was able to find accurate models and use in this design, saving some time on me having to create them manually. Again, this may seem like a waste of time, but these models really help to work through all the complexities of the design, reducing risk and wasted material of building it wrong. With component models in hand, they get added to the design and loosely positioned based on the arc of the monitor. The first sidewall was created, then the remaining buttons were added. Initially, this design is being set up using wood for the side rails, which will save money over milling it from billet aluminum, although I'm not quite sure if in the final product I may go with the aluminum. It's just going to cost a bit more. Next, with the side arc designed, I'm able to agree to the acrylic arc. They'll be used to conceal all the components, kind of in the traditional blackout design that I did in my handhelds. Now, before I get ahead of myself, I plan to use the monitor stock base, and for that I obviously had to model it to the exact dimensions so that I can ensure that the correct mounting location as well as size, orientation, and the aesthetic of the preview. Next, to support the acrylic body, I added some 1/4-inch side frames. Then mirror them over to the other side. These will be solvent welded to the acrylic during assembly. As I'm designing this assembly, I'm thinking through how each of these parts will be fabricated, what technology, which of my machines, and any limitations, so that while the parts of the design could be done 100 ways, I'm keeping in mind that the design is conducive to the machines and limitations that my shop has. So keep that in mind as we walk through this. The control buttons are organized and the layout's finalized. I've also added side buttons in this case to the design to use for like pinball games, which should be pretty cool with this dynamic interface. Next, I shift to design a cross-member mount for the unibody design. This design will leverage 1-inch dowels to support the frame. They're replicated to strategic locations in the body to support the design. Dowels are then created and mounted using joints and the new mount points. Next, using the dowel crossmember, mounts are designed to support key features like the joystick, the button assembly, and while the 1/8-inch acrylic, which the face is made up, is fairly rigid, these underlying supports will provide more rigidity to the components for better competitive gameplay. These are extruded with holes that mount on the dowels. Mount holes are then extruded through the face and mount brackets to finish off the components. With the main components in place, next I added models that represent the speakers that'll be used. Angling them outward to the sides will give great sound and hopefully wider stereo for those games that support it. Mounting holes are then added to the side rails to support the new speakers. As we move along, next I move to create the base mount. Spanning 2 of the dowels, I extrude a solid mount for the base, and we'll come back to finish this off later. For now, to keep the cabinet cool, I position and mount my slim 120mm fan to the upper back of the unit. Position it in a good location, then I design the mount that spans the 2 upper dowels. These allow me to mount the fan out of the way. An additional mount's needed for the TV controls as well, and following the same pattern, I took dimensions on the breakout board and then extrude another mount for the control board. These are all intentionally created separately for a couple reasons. 1, the size of the objects are easier to 3D print, and 2, it provides some flexibility to move and adjust them around in final fit and assembly. Next, I sneak in some recessed areas for LED strips. These will edge light a 1/8-inch acrylic side plate that's sandwiched between the side wood and the 1/4-inch subframe. I'll add some holes for wire routing and we're good to go. Next, to mount the wood sides, I decided to recess an area in the wood that will conceal the screw heads and provide some additional style to the cabinet. Using the same 1/4-inch black acrylic, inlays are created to cover the screw heads and finish off the sides. With all the internals complete, I extrude the back panels, which will be created from 1/8-inch black acrylic. The panel is then split into an upper and lower panel, which will join at the base mount. On the top panel, I cut fan vent holes to draw air into for circulation, and then shift back to the base mount to fortify the mount design. Now, for this particular design, to provide some flexibility, I designed a pivot joint that will allow the machine to move around 30 degrees vertically while maintaining a level base orientation. After some final cleanup and adding a cutout to the back panels, the base is good to go. The interesting aspect to this base mount is that the design will be printed in place as a complete joint, and will leverage a compressed silicone tubing to provide active feedback and maintain its position, while still allowing for fluid movement. Well, that's a plan at least. We'll have to print it and test it before we know for sure. With that, the only thing left is to extrude venting holes in the lower panel, which will provide exhaust ports for the air being brought into the enclosure by the fan. Now, check out this sexy thing. I think it looks clean, modern, and I can't wait to finish it up. And with that, we're good to go on the design. Well, at least ready to order the remaining parts and fabricate it. And for that, you'll need to tune in next time, because that's going to do it for today. Hopefully you enjoyed this look at designing a brilliant looking and performing Bartop arcade, now officially named the Barcader. When the project's complete, the digital files for this will be available from my website, and the parts list will be listed in the description below. Also, if you want to support this work, subscribe to the channel, ring that notification bell. It'll keep you in the loop on future updates. If you like this particular video, give it a big thumbs up, and that kind of lets me know you enjoy this work. Leave a comment below if you have any questions about the design or the project, or any ideas you may have. They may get incorporated into the final project. In the meantime, be safe, have fun, and I'll see you next time. Hey, if you liked the video, please subscribe to the channel. It's how we're building the community. Also allow me to bring better content. Also check me out on these other social networks. There's lots of cool stuff there too.
I said empty your mind. Be formless, shapeless.